Hello, on this video we're going to talk a little bit about Delegate. So what's Delegate? So Delegate is a function pointer, or it is a shortcut to a function. So Delegate is a function pointer or a shortcut to a function. So since this is a shortcut to a function pointer, then we're going to need some functions. And I'm going to create a couple of functions here. It prints I am function A and the value of the parameter. So that's all it does. So if I call this function here and I pass 10, it prints 10, and it says and also from function A. So I'm gonna copy this function because I want two other functions very similar to this one here. I'm gonna change the name, and instead of X I'm gonna put Y here. So Y, and this is function ABC, and my variable is going to be Z. Function C, variable is Z. I need to fix these two. So notice that the signature of the function, of these three functions, are very similar. They're all voids, and they all take one parameter, integer. So it is very important, in order for this to work, the signature must be the same, this returning type must be the same, and the parameter must be the same. So if you notice that on this function I got voids and an integer as a parameter, just one single integer. On the function B it is also voids and also integer, and function C is also void and an integer. Now the name of the parameter does not matter, and the name of the function also does not matter. What matters is the signature. So now I have three functions that are very similar as far as signature is concerned. So this is my functions. Now let's create the delegate now. So the delegate is going to be public delegate voids, and that's very important here. So this signature, the void, the returning type must be the same of all of your functions. So the void, the returning type must match. Void my delegate functions, and the parameter also must match. So if my functions are all integer, these also must be integer. Now you can't name this parameter exactly the same as here and here and here. Now I'm naming it differently only to show you that it doesn't have to be the same, but you can if you want to. So now I have a delegate, and the signature of this delegate is void, returning type is void, and the parameter is an integer, single integer, very important. So remember, this must match all the functions that you will delegate, and the parameter also must match. So far we're not using the delegate yet. So we call function A, and by pass 10 we can call function B. Now we can pass 20, and we can call function C, and we can pass 30. You got function A prints 10, function B prints 20, function C prints 30, and that is nice. So we like that. Now let's take a look on the delegates now. I'm going to just comment this piece of code here. So let's create a delegate function here. So delegate function, I'm going to call it A, equals new delegate functions, and now I'm gonna pass here as a parameter the name of the function that I want to delegate as A. So the name here of the function is function A, so the parameter is the function A. So now every time I call function delegate A, I'm actually calling the function A. So let's make a test. So A, and if I want to pass 100, so now every time I call A, I'm actually calling function A. So let's run this guy. There it is, you call function A. Now you can do the same thing with B. So delegate functions, B equals new delegate functions, and now I'm going to pass as a parameter the second function, function B. And sure enough, if I call the function B and I pass a value, I want to pass 30 this time. Now if I run, function A passes 100, and the func B, which is delegated by B, passes a 30. And I can do the same thing with C. So delegate functions, C equals new delegate functions, and this time I want to pass function C. And sure enough, if I pass something here, I'm going to pass 20 this time. So when I call C, it's actually calling function C. So there it is. So you must be asking yourself right now, what's the advantage of delegate? Because we can do exactly the same thing only by calling the functions. So why we're having so much more code here to do the same thing? Well, here it is. Here's the point of having delegates. So I'm going to create one more delegate function. I'm going to call this all funcs, and this is going to be equals A plus B plus C. And what happens now, every time I call all funcs, I'm going to call function A, function B, and function C at the same time. Now this is why it is important to have the same returning type and the same parameter for all of your functions. So I'm going to comment it out here, this code, so you will not call the A, nor the B, and nor the C. But I am call all funcs, and I'm going to pass a value here. I'm going to pass 55. So now when I call all funcs, what I'm actually calling is A, B, and C. In that sequence, by the way. So I run it, now it's calling all functions. Now the beauty of this is that if you have 100 functions, then you do not need to make 100 function calls. You call one function only, and then it calls all the functions for you. And also the nice thing about it is that you can start adding or subtracting functions. So when I call this, I'm actually calling A plus B plus C. Now if I decide that all functions minus equals B, what happens here, I'm subtracting B from the delegate. And if I call all functions again and I pass a second parameter, let's pass 33 this time, then you will see the difference. I'm just going to put a couple of spaces right here so we know the difference in the console. So if I run this guy, now notice that the first time you call all funcs, you call function A, B, and C, and then before we call all funcs again right here on line 27, we subtract function B. And now what you call it function A and function C only. So the beauty of delegate is that you can add and subtract functions on the fly. And if you have a whole bunch of functions, then with one function call, with one delegate function call, you can call many functions.